For a long time, nothing happened. The sky stayed quiet, dark, patient. Out beyond the orbit of Mars, a small object moved through the cold, like it had done 1,000 times before. No tail, no glow, no drama, just a faint dot sliding across black space. Its name was simple: 3I ATLAS. To most people, it meant nothing. Another rock, another visitor, another line in a database no one outside science would ever see. And for months, that's exactly how it felt. Astronomers tracked it the way they track everything else. Slowly, carefully, almost casually. Night after night, telescopes followed its path along the ecliptic. Its speed made sense. Its direction made sense. Its silence made sense. It was cold, distant, predictable. Just another traveler passing through the waiting sky. But space has a habit of hiding its secrets until the last possible moment. And this one was waiting, as 3I ATLAS drifted closer to the sun. Teams around the world prepared for routine observations. Nothing dramatic, just numbers, light levels, reflections, movement. The kind of data you expect to forget 5 minutes after you log it. No one stayed late. No one held their breath. No one felt fear. Not yet. Then the first full observation arrived. It didn't announce itself with alarms or flashing screens. It appeared quietly as a curve on a graph, a gentle rise and fall in brightness. A light curve, something astronomers know by heart. Every rotating object has one. Spin, reflect, dim, repeat. It's like a fingerprint, familiar, comforting. Except this one wasn't. At first, it looked like a mistake. A small bend where there shouldn't be one. A slope that felt off. Too smooth in places, too sharp in others. The numbers were checked, then checked again. Same result. Maybe dust, maybe ice, maybe a shadow effect. They ran the models, changed assumptions, adjusted angles, ran them again. The curve didn't move. It bent, but it didn't break. And that was the problem. Natural objects wobble. They jitter. They carry chaos in their data. Tiny imperfections from uneven surfaces, random debris, messy rotations. But this curve was calm. Too calm. It rose with intention, fell with restraint, almost like it knew when to stop shining. Someone finally said it out loud, half joking, half uneasy. That's not how rocks behave. The room went quiet. Outside, the night sky looked the same as it always had. Stars burned. Planets held their lanes. Space gave no hint that anything was wrong. But on the screen, something had changed. 3I ATLAS wasn't just reflecting sunlight. It was controlling how it reflected. That single thought lingered longer than it should have. They zoomed out, compared earlier data, compared it to comets, to asteroids, to interstellar debris. Nothing matched. The reflectivity was inconsistent, but not random. Brightness increased where it should have dropped. Dips appeared where models predicted smooth curves, like a heartbeat skipping, then correcting itself. As days passed, more observations came in. Different telescopes, different countries. Same curve. No one used big words yet. No one dared. Science is careful that way. It moves slow, even when something feels fast. But late at night, off the record, whispers started to form. What if it's not tumbling? What if it's oriented? What if it's doing this on purpose? The idea felt ridiculous, almost embarrassing. After all, space is full of weird things, strange shapes, odd chemistry, unknown physics. You don't jump to conclusions, but you don't ignore patterns either, and this was becoming a pattern. As 3I, ATLAS continued toward perihelion, the sun's light grew harsher, brighter, more unforgiving. Most objects would respond in predictable ways, heating up, shedding material, growing chaotic. But the curve stayed disciplined, measured, as if the object was watching the sun approach, as if it knew what was coming. Somewhere between routine and disbelief, a shift happened. Astronomers stopped asking, "What is it doing?" and started asking, "Why?" Why does the light peak here? Why does it drop there? Why does it stay stable when it shouldn't? The data didn't scream danger. It whispered intelligence. And whispers are harder to ignore because they make you lean in. By now, 3I, a TLAS, had become more than a dot. It was a question moving through space, a quiet challenge to everything we thought we understood about visitors from beyond our system. Still, the sky above Earth stayed silent. No flashes, no signs, no answers, just a curve on a screen, and the uncomfortable feeling that the universe had blinked first. For centuries, humanity has stared upward, waiting for something to happen, waiting for proof that we are not alone, waiting for the sky to speak. And when it finally does, it doesn't shout, it waits, just like this, just like 3I ATLAS, drifting closer, holding its shape, keeping its secrets, and asking a question no one was ready to answer yet. What did we just discover? At first, it looks small. So small, it's almost easy to miss. Just a few numbers drifting higher than expected. A brightness spike here, another there. Nothing dramatic, nothing loud. But space doesn't lie quietly for long. As reflectivity data sharpens, scientists begin to notice something unsettling. Not chaos, not noise, not the messy scatter you'd expect from dust or ice breaking away. Instead, clarity. The brightness jumps are clean, sudden, precise, too precise. In space, light usually fades gently. It rises and falls like a slow breath. Objects rotate, surfaces catch the sun, then let it go. It's a rhythm shaped by chance and physics. But 3I, ATLAS, isn't breathing. It's blinking. One moment it's dim, then suddenly bright, then steady again. No gradual climb, no soft decay, just on and off. At first, scientists blame the usual suspects: dust clouds, outgassing, small fragments reflecting light at the wrong angle. They test for all of it. Nothing fits. Dust should scatter light unevenly. Ice should create fuzzy halos. Rotation should cause smooth cycles, not sharp edges. But these jumps aren't fuzzy. They aren't smooth. They're deliberate, like a switch being flipped. The numbers come in from different instruments. Different angles, different nights, different parts of the world. Same result. Brightness increases by the same amount at the same intervals, then stops. No decay, no drift, just control. Someone overlays the data points on a clean graph. The line doesn't wobble, it steps. Up, hold, down, hold. And that's when the room changes. Not with panic, not with excitement, with discomfort. Because scientists are trained to expect randomness. They trust it. Randomness means nature is doing its thing. But order is suspicious. They compare the reflectivity to known objects. Metallic asteroids, carbon-rich comets, even rare crystalline structures. Still, nothing. The surface behavior doesn't match rock. It doesn't match ice. It doesn't match debris. It matches decision. That word isn't written anywhere, not in reports, not in emails, but it sits quietly in the air. Decision, as if the object is choosing when to shine. As if something is controlling how much light it gives back to the sun. Late at night, one researcher reruns the model. Slower this time. Strips out assumptions. Lets the data speak without explanation. The pattern remains. He leans back in his chair, stares at the screen longer than he should, because the pattern doesn't just repeat, it responds. When solar intensity rises, the reflectivity adjusts. Not instantly, not passively, thoughtfully, almost cautiously, as though 3i, ATLAS, is aware of the light touching it, aware enough to manage it. This is the first time someone writes the word anomaly in bold, not as a placeholder, not as a technical note, but as a warning. Emails begin to circulate, careful ones, polite ones, filled with phrases like unexpected behavior and requires further review. But between the lines, something heavier forms. A realization. If this were a natural object, it should be failing by now. Surfaces should be heating unevenly. Materials should be degrading. The signal should be breaking apart. Instead, it holds. The reflectivity stabilizes again, like the object has finished making a choice. And then it waits. The sun grows brighter with each passing day. Perihelion creeps closer. The zone where fragile things unravel waits ahead like a test. Most comets panic here. They erupt. They shed mass. They become unpredictable. But 3i, a TLAS, doesn't panic. It prepares. The brightness jumps one more time. Same magnitude, same duration. As if someone pressed the same button again and expected the same result. At this point, denial feels harder than belief. The data doesn't ask for imagination. It demands honesty. Something about this object is different. Not alive. Not speaking. Not waving at us across the dark. Just behaving with restraint, with intention. And intention is dangerous. Because once you allow for intention, you must allow for origin. Who built it? Why does it react this way? And why now? No one says it publicly. Not yet. But the question forms quietly in 100 minds at once. If this is being controlled, then by what? Or by whom? Outside the labs, the world goes on. Cities glow. Screens scroll. The sky above looks calm and empty. No one looks up and sees danger. But somewhere beyond Mars, a cold object continues its journey, shining only when it wants to, holding its pattern, guarding its surface, refusing to explain itself. And with every controlled flash of light, it sends the same silent message back toward Earth. This is not random. And whatever comes next won't be either. It begins the way most strange things do, quietly, during a routine scan, long past midnight. A technician watches numbers scroll across a screen. Nothing dramatic, just another shift, another data set, another night listening to the universe say nothing until it does. At first, it looks like interference, a small rise in the signal, then a drop, then another rise, subtle, easy to dismiss. Space is full of noise. Solar wind, cosmic rays, distant stars flickering for no reason at all. So the technician marks it, flags it, moves on. But the signal comes back, not stronger, not weaker, the same. Same timing, same spacing, same shape. A pulse, slow, steady, deliberate, like something tapping on the dark. The next scan catches it again, and the one after that. 3 pulses, perfectly spaced. That's when the screen stops feeling routine. Across the world, in other observatories, other people are staring at their own data. Different telescopes, different systems, different skies. And they're seeing it too. A rhythm buried inside the noise. At first, no one connects the dots. Everyone assumes it's local interference, a software hiccup, a calibration issue. Until someone asks the question no one wants to ask yet. Is anyone else seeing this? Minutes later, replies begin to arrive. Yes. Yes, but faint. Yes, same interval. The room grows quiet again. That same heavy quiet from before. The kind that settles in when coincidence starts to feel unlikely. They overlay the signals. The pulses align. Not roughly, not approximately, exactly. Same timing, same duration, same pause between them. Noise doesn't do that. Randomness doesn't synchronize itself across continents, but this does. The signal repeats every few minutes. Not fast enough to feel urgent, not slow enough to feel natural, measured, intentional, like a heartbeat you weren't meant to hear. Some try to explain it away, maybe solar reflections, maybe a background star rotating just right, maybe an instrument artifact shared across systems. But the math refuses to cooperate. The pulse doesn't drift. It doesn't decay. It doesn't evolve. It just repeats. On, off, and then silence. For a moment, everyone relaxes. Maybe it was a fluke after all. A rare alignment. A cosmic joke. Then it starts again. Same pulse, same timing. As if it waited for attention. Someone labels the file carefully. Neutral words, technical language. But privately, a different word begins to circulate. Signal. Not broadcast, not message, just signal. Because signal implies origin. It implies source. And sources imply intent. The pulses don't carry information, at least not in any known way. No modulation, no language, no pattern we recognize as communication. But they carry something else, presence. The kind that makes you sit straighter in your chair. The kind that makes you suddenly aware of how small Earth feels. For decades, scientists have searched the sky for patterns like this. Listening for alien radio waves, hunting for clear signs of intelligence. They always imagined it would be loud, obvious, impossible to ignore. But this isn't loud, It's subtle, restrained, almost polite. The pulse comes from 3i, a TLAS. The same object already refusing to behave like debris. The same object controlling its reflectivity. The same object gliding towards perihelion without fear. Now it's pulsing, and no one can say why. They zoom in, slow it down, speed it up, strip away background noise. The pulse remains untouched, perfectly timed. Someone compares it to rotating machinery, another to thermal cycling. Someone else says it looks like regulation, not emission, as if the object isn't sending energy out, but managing something inside. That idea lands hard, because management implies system. System implies design, and design implies purpose. The pulses don't grow stronger as the sun gets closer. They don't weaken either. They stay constant, like a metronome keeping time in the dark. Tick, pause, tick. Every attempt to force a natural explanation leaves more questions behind. If it's rotation, why doesn't the timing change? If it's heat, why is it so stable? If it's chance, why does it repeat? The silence between pulses becomes just as important as the pulse itself, because silence is a choice too. At one observatory, someone jokes nervously that it feels like the object is checking in. No one laughs. Instead, a new protocol is quietly suggested. Keep watching. Don't interfere. Don't announce anything yet. Just observe. Because if this is artificial, the worst thing you can do is blink. As days pass, the pulse continues. Always the same. Always calm. Never urgent. Like it's not trying to get attention. Like it assumes attention is already there. News of the anomaly spreads slowly, carefully, within closed circles. No headlines, no alerts, just long nights and tired eyes. People who've spent their lives studying dead rocks now find themselves staring at something that refuses to feel dead. The universe has always been noisy, chaotic, indifferent. This feels different. This feels measured. And measurement is a form of intelligence. Late one night, someone overlays the pulse timing with the earlier reflectivity jumps. They line up. The brightness changes, the pulses, the thermal control. All part of the same behavior, not separate mysteries. One system, one pattern, one unknown. By now, the question has changed. It's no longer, what is this? It's who decided it should behave this way. Outside, Earth keeps spinning. Most people sleep. Some scroll. Some dream. Above them, beyond the planets, an object from another star system pulses softly in the dark. Not calling out. Not hiding. Just existing. With rhythm and restraint. And for the first time, the idea settles in that maybe the universe isn't as silent as we thought. Maybe it's been speaking all along, and we're only just learning how to listen. By now, no one is calling it routine anymore. Every new observation of 3i, ATL-AS arrives with tension baked in. Not fear, not excitement, just that quiet pressure in the chest that says, something is wrong, and you don't know why yet. This time, it's the thermal data. Heat, the simplest thing in space. Objects get closer to the sun. They warm up. They move away. They cool down. It's one of the first rules you learn. And 3i. A TLAS breaks it without hesitation. The first readings come in during deep cold. far from the sun's grip, a place where temperatures are supposed to stay brutally low, flat, lifeless. But the sensors don't agree. The temperature rises. Not slowly, not gradually. Quickly, too quickly. At first, it's written off as error, a glitch, a calibration issue. Thermal sensors are sensitive. Space is messy, so they rerun it. Same result. They switch instruments, cross-check with different wavelengths, compare readings from separate observatories. The warmth is real. 3ITLAS is heating up, where there is no heat source. That alone is disturbing. But what comes next is worse. As the object drifts closer to the sun, entering regions where radiation grows intense, something unexpected happens. It cools. Not just relatively, actively. The temperature drops during solar exposure, flattening instead of spiking. Like heat is being shed on purpose. Like the object is refusing to absorb what the sun is offering. Someone finally whispers the thought no one wants to voice. That's backwards. Because it is. Natural objects don't cool themselves when bathed in sunlight. They don't regulate. They don't adapt. They suffer. They crack. They shed. Mass. They unravel. But 3I, a TLAS, doesn't unravel. It stabilizes. The thermal pattern forms a shape no one has seen before. Spikes where there should be calm. Calm where there should be spikes. It's not chaotic. It's controlled. And control changes everything. A comet under solar stress behaves like a wounded thing. Violent, unstable, loud. This object behaves like something trained. Like something that knows the limits and stays just inside them. The data is plotted over time. Heat up here. Cool down here. Repeat. Not random, not accidental. Consistent. As if there is an internal system balancing energy, moving heat away from exposed surfaces, redistributing it, storing it, releasing it. Those are words usually reserved for machines, not rocks, not ice, not debris from a broken star. One researcher stares at the thermal curve longer than anyone else. He traces it with his finger, slowly, as if feeling for something hidden. Finally, he says it. This looks regulated. No one responds right away, because regulation implies intent, and intent implies design. They try to force natural explanations into the data. Exotic materials, unknown chemistry, rare interstellar ice mixtures. But every model breaks somewhere. If it's ice, it should sublimate. If it's metal, it should heat unevenly. If it's rock, it should fracture. 3I, a TLAS, does none of these things. It behaves like a sealed system, a closed loop, as though it was built to survive this exact journey. That thought lands heavily, because perihelion is coming, the zone where objects are tested and usually destroyed. Temperatures spike violently there. Radiation becomes merciless. Even the strongest natural bodies struggle. But 3I, a TLAS, seems to be preparing. The thermal changes begin earlier than expected, long before the sun should matter this much. Almost like anticipation, almost like memory, as if the object has done this before. At night, one of the scientists steps outside the observatory. The air is cold. The stars are sharp. Everything feels normal, too normal. Somewhere out there, an object from another star system is breaking rules we thought were unbreakable. Not loudly, not dramatically, quietly, methodically, the thermal data keeps coming. Each new pass confirms the same story. Heat where there should be cold. Cold where there should be heat. It's not survival by luck. It's survival by management. And management requires awareness. That idea is never written down. Not officially. But it spreads anyway, moving from mind to mind like a low current. Is 3i, a TLAS, managing its own heat? If so, why is it protecting something inside? Preserving a structure? Shielding a system from damage? The questions multiply faster than answers ever could. Somewhere between midnight and morning, someone overlays the thermal pattern with the earlier pulse data. They align. The pulses coincide with temperature shifts. Heat moves when the signal appears. Cooling follows in measured response. One system, one behavior, one unseen logic. By now, denial feels childish. This is no longer about whether something strange is happening. It's about admitting what kind of strange this is. Not chaos, not randomness, not an accident drifting through space. This is order, and order in space is rare. Order that protects itself is rarer still. As the sun grows larger in the sky of 3i, ATLAS, the object remains calm, stable, silent, like it's confident, like it knows something we don't. Human history is full of moments like this, times when data arrives before understanding, when truth shows up quietly, without permission. Most of the time, we ignore it. This time, we can't. Because if this object is truly regulating its own heat, then it was built with purpose, and purpose implies origin. Someone made it. Something made it. And it didn't make itself known. It just passed into our system, tested our assumptions, and kept going. The universe didn't announce its secret. It let us notice it. And as 3i, ATLAS continues toward the most dangerous part of its journey, one unsettling thought settles in for good. This object is not afraid of the sun, and that should scare us more than anything else. There is a line in space that most objects never cross intact. A quiet boundary, invisible, unforgiving. Astronomers call it perihelion, the point where the sun stops being a light in the distance and becomes a weapon. This is where comets die. Ice turns violent. Rock fractures. Tails explode outward like screams frozen in motion. Even strong bodies lose control here. They shed mass, spin wildly, and break apart under pressure they were never meant to endure. So when 3i, the TLAS, approaches this zone, everyone braces for the end. Not emotionally, scientifically, they expect silence. Signals should collapse. Thermal control should fail. The careful patterns should dissolve into noise as the sun tears the object open. That's how this always ends. Except this time it doesn't. As 3i, ATLAS crosses into the danger zone, the first readings come in. And instead of chaos, there is calm. The signal doesn't weaken. It doesn't stutter. It doesn't disappear. It stabilizes. Almost tightens. The pulse becomes cleaner, more consistent, less affected by background noise than before. That alone feels impossible. The sun's radiation here is brutal. It overwhelms instruments. It floods sensors with interference. Even Earth's strongest telescopes struggle to see clearly. But somehow, 3i A TLAS cuts through it, like it was designed to operate here. Someone quietly checks the timestamps, checks the distance, checks the solar intensity again. No mistake. This is the zone where objects unravel, and 3I, a TLAS, is holding together. Worse than that, it looks comfortable. The thermal readings remain controlled. No runaway heating, no violent spikes, no structural collapse. The reflectivity stays measured. The light curve doesn't fracture into noise. Instead, everything becomes more precise, as if the object has entered the phase it was built for. This is the moment when disbelief spreads beyond curiosity, because surviving perihelion isn't just unlikely. It's unprecedented. No natural interstellar object has ever behaved like this. Not in recorded history, not even close. Someone compares the data to hardened spacecraft, to solar probes engineered by humans to skim the sun's surface. The comparison is uncomfortable. Those machines require extreme materials, active cooling, precise engineering, years of planning. 3I. A TLAS has none of that, at least none that we can see, and yet it performs. The signal strengthens slightly. Not dramatically, just enough to be noticed, enough to suggest stability under stress, like a voice that doesn't crack even when pressure rises. That's when the room changes again. Because this is no longer about strange behavior. This is about survival. And survival implies foresight. Someone finally says it out loud, not as a theory, but as a question. How does something survive here? No one answers, because every answer leads somewhere dangerous. If it's natural, then physics is missing something fundamental. If it's artificial, then intent is undeniable, and intent changes our place in the universe. As perihelion passes, the object doesn't erupt. It doesn't shed material. It doesn't scream its presence across space. It glides through, silent, stable, unbroken. The sun throws everything it has at it. And 3I, ATLAS, doesn't flinch. That silence is heavier than any explosion could be, because destruction would have been easy to explain. Survival is not. The pulse continues, same rhythm, same spacing. No panic, no urgency. As if the object always knew this moment was coming. As if this was the point of the journey. Someone notices something subtle in the data. The pulses align more tightly with the thermal regulation now. Heat moves exactly when the signal appears. The system is working harder, but it's still in control. Like a machine under load, and machines under load reveal their purpose. Late into the night, a researcher rewatches old footage of comets at perihelion. Bright chaos, uncontrolled beauty, destruction written in light. Then he looks back at 3I, at TLAS. Nothing. No tail, no flare, no surrender. Just restraint, just discipline, just passage. That's when the thought becomes unavoidable. This object isn't just surviving the sun, it's using it. Solar energy floods the system, and 3I ITLAS absorbs what it needs, rejects the rest, and moves on. No waste, no panic. Efficiency. And efficiency is never accidental. As the object begins to exit the perihelion zone, still intact, still silent, the data settles into a terrifying consistency. Everything held, every system functioned. Nothing broke. The test that destroys worlds did nothing to this. At that moment, something shifts. Not in the data, but in the people watching it, because this is the point of no return. You can't unsee survival like this. You can't go back to calling it a rock. You can't pretend it's just another visitor. Whatever 3I ATLAS is, it was built to endure. And if it was built to endure this, what else was it built to endure? The sun fades behind it as it moves on. The most dangerous part of the journey is over. For us, the danger is just beginning, because now there's no excuse left, no natural explanation still standing. Only one question remains. Hanging in the quiet after perihelion, if something can pass through the sun's fire untouched, what else can it survive? And why did it choose to pass through our sky? Right now, at first, they hoped the chaos would return. That sounds strange, but chaos would have been comforting. Chaos means nature is still in control. After perihelion, everyone expects the data to unravel. Stress usually leaves scars. Tiny irregularities, random spikes. The mess that proves something barely survived. So they feed the new observations into advanced models, expecting noise. Instead, the noise disappears. The randomness peels away like fog. What remains underneath is something far worse. Structure. Clean, repeating structure. The models do exactly what they were built to do. Strip out coincidence. Remove background interference. Flatten the messy edges that come from chance. And when they finish, the pattern is undeniable. The pulses repeat with the same internal spacing. The thermal shifts follow the same sequence. The reflectivity changes obey the same timing rules. Not sometimes, every time. It's like discovering a rhythm beneath static, a song hidden inside silence. Someone overlays weeks of data on top of each other. They line up perfectly. No drift, no decay, no mutation. Natural systems change under stress. They evolve. They degrade. They surprise you. This doesn't. It behaves like it's locked, like it's following instructions. That's when the phrase starts appearing in private notes and quiet conversations. Patterns without chaos. In space, chaos is the default. Gravity pulls unevenly. Surfaces are rough. Energy flows unpredictably. Patterns happen, but they're fragile. They break easily. This one doesn't. The more data you add, the clearer it becomes, not more confusing. Clearer. The models test every remaining natural explanation. Exotic physics, rare materials, unknown interstellar chemistry. Each one collapses under pressure. If it's natural, it should slip somewhere. If it's random, it should fail eventually. But the pattern holds. Always the same order, always the same restraint, as if something is checking its own work. A researcher runs a simulation where randomness is forced back into the system. Artificial noise is injected, variables are loosened. The real data refuses to match. It's too disciplined. Someone finally says the quiet part out loud. Accidents don't repeat themselves like this. That sentence lands harder than any theory, because accidents are messy. They leave fingerprints. They make mistakes. This doesn't. It behaves like a design that has already been tested, already refined, already finished. The idea spreads slowly, not as panic, but as resignation. You can only fight the data for so long before it wins. And the data is saying one thing over and over again. This is not chance. That realization brings a strange kind of fear. Not the kind that makes you run, but the kind that makes you still. Because if patterns don't form like this by accident, then intention must exist somewhere. Not necessarily intelligence, like ours. Not necessarily communication, but intention. A goal. A reason for behaving this way. They search for errors again. Recheck assumptions. Question instruments. Question themselves. Everything checks out. The universe, it seems, has left no wiggle room this time. One of the scientists compares the data to early machine learning systems, how they repeat behaviors once trained, how they minimize waste, how they favor stability. No one responds. Because that comparison opens doors no one is ready to walk through yet. If this is a system, then it has limits. Limits imply boundaries. Boundaries imply purpose. And purpose implies origin. The object isn't changing because it doesn't need to. It's already doing exactly what it was made to do. That thought settles in slowly, like a weight. People begin to look at older data differently now. Earlier observations that once seemed dull suddenly feel loaded. The waiting sky, the controlled reflectivity, the pulse, the heat regulation, the survival at perihelion. They aren't separate mysteries. They're chapters of the same story, a story that was unfolding long before we noticed. And that's when the most unsettling question appears. If this object carries such precise order, what happens when it reaches the part of its journey that actually matters? Because so far, everything could be preparation. The pulses continue, still calm, still measured, still indifferent to our growing unease. No escalation, no reveal, just persistence. Like a machine running in the background of the universe. Humanity has always believed that order comes from us. That intelligence builds patterns and nature destroys them. But 3i ATLAS flips that belief upside down. Here is something in deep space, far from stars, far from life as we know it, maintaining order better than anything we've ever built. And it's not asking for attention. It's not demanding belief. It's simply continuing. The more we observe, the less comfortable we become. Because randomness would have let us sleep. Patterns do not. Patterns demand explanation. And explanation leads to uncomfortable truths. Somewhere beyond the planets, an object keeps its rhythm, unaware of our debates, unchanged by our fear. It doesn't care what we call it. Rock, machine, artifact. Names don't matter. What matters is this. The universe has shown us order where we expected chaos. And once you see that, you can never unsee it. The question is no longer, what is it? The question is, what happens when a pattern reaches its destination? No one announces it. There's no meeting, no headline, no dramatic moment where someone stands up and says the words out loud. It happens the way dangerous ideas always do, quietly, late at night, in private messages, in careful sentences that leave room for denial. It starts as a comparison, not a claim, not a theory, just a comparison. This behavior looks less like debris and more like a system. The word machine isn't written yet, not directly, because once you write it, you can't take it back. Up to now, every strange behavior of a TLAS could be argued away on its own. Odd reflectivity, unusual pulses, impossible thermal control, survival at perihelion, each one uncomfortable but survivable. Together, they form something else, something cohesive, something that behaves the way designed things behave. The scientists involved know the risk. Careers have ended over less. History isn't kind to people who jump too far ahead of evidence, so they're careful. They don't say machine, they say mechanism. They say active system. They say non-passive behavior. But in their minds, the picture is already clear. Debris reacts. Machines respond. Debris breaks under stress. Machines adapt. And 3i, a TLAS, has been adapting since the moment we noticed it. The pulses weren't random emissions. The heat shifts weren't accidental. The reflectivity wasn't sloppy. It all worked together, like parts of a single process. Someone finally dares to ask the question that has been circling the room for weeks. What if this isn't a natural object at all? No one laughs. That's the part that matters, because disbelief would have been easier. Silence means the idea has already taken root. They begin listing what a machine would need to do in deep space. Regulate heat, manage energy, survive radiation, maintain structure, remain stable under extreme conditions. Then they compared that list to the data. Every box is checked, not loudly, not perfectly, but well enough. Better than chance, better than coincidence. Someone else raises another question. If it's a machine, why can we see it at all? That question lingers, because machines designed to hide well. This one doesn't hide. It just doesn't announce itself either. It reflects light when it chooses, pulses when it chooses, manages heat without broadcasting effort, almost like it doesn't care if it's seen, or like being seen doesn't matter to it. That thought is unsettling in its own way, because attention usually changes behavior. This thing hasn't changed at all, as if our observation means nothing. Or worse, as if it expected it. The discussion shifts carefully to origin. Not who yet, just where. Interstellar space is vast, empty, violent, hostile to complexity. Anything built out there would need purpose. No one builds a machine without reason. So why send something like this drifting through star systems? Some suggest it could be ancient. A relic, something left behind long ago, still running a task it was given before Earth even formed. Others imagine it as a probe, not watching us specifically, just passing through, collecting data, moving on. A silent surveyor. No greetings, no warnings, just observation. That idea chills the room. Because probes imply a builder that doesn't need to be present. And that builder doesn't need to be nearby. They talk about scale. If something can build machines that survive perihelion, interstellar travel is trivial to it. Distance becomes irrelevant. Time becomes flexible. Civilizations like that don't rush. They wait. Another scientist asks the hardest question yet. What if this isn't for us at all? What if Earth is just background, just another point of data? That idea feels worse than being targeted, because it suggests we're insignificant, not special, not chosen, just noticed. Accidentally, they pull back again, reground themselves, remind each other to stay scientific, to avoid narrative traps. But the narrative has already formed, because stories are what humans use when facts become overwhelming. And the story emerging here is simple. This object behaves less like a thing and more like a tool. Tools are built to do something, So what is 3I TLAS doing? It's not communicating. It's not changing course. It's not reacting to us. It passed the sun without damage. It's still moving. Maybe that's the point. Transit. Movement through star systems without stopping. Without interacting. Without risk. A machine designed to travel forever. The room grows quiet again. Because eternity is not a human concept. It's not something we design for. If this machine is real, it wasn't built with us in mind. That realization shifts the emotional weight of everything. This isn't a message. It's a reminder. The universe may already be full of things moving quietly through the dark, doing work we don't understand, for reasons we will never know. 3I. ATLAS might just be the first one we noticed. They decide not to say anything publicly. Not yet. Not because they're hiding the truth, but because they don't have the language for it. How do you tell the world that something artificial may have passed through the inner solar system and didn't care? So they keep watching. They keep listening. They keep measuring. Because if it's a machine, it might do something next. Or it might not. And that uncertainty is worse than fear. As 3I, ATLAS continues its journey away from the sun, unchanged and indifferent. One final question hangs over every late-night observation. If something was built to cross stars silently, what was it built to survive? And more importantly, what was it built to last long enough to see? At first, it spreads the way rumors always do, quietly, unevenly. Through corners no one watches closely enough. A screenshot here, a leaked chart there, a message forwarded one too many times. Most people don't notice it right away. The world is loud, always moving, always distracted. But this time, something slips through. A graph with repeating pulses, a thermal curve that makes no sense, a note in the corner that simply reads, non-random behavior, and once that door opens, it doesn't close again. Online forums light up first. Amateur astronomers, data analysts, people who know how to read numbers, even when they don't know what they mean. They ask careful questions. Why does the signal repeat? Why didn't it break at perihelion? Why does it look controlled? The word 3I, ATLAS, begins to trend quietly. Not loudly enough to alarm anyone, just enough to be noticed. Then mainstream science communicators catch it. They try to stay neutral. They explain uncertainty. They emphasize caution. This doesn't mean aliens. This doesn't mean intelligence. This doesn't mean anything yet. But the footage keeps circulating, and people can see what they're not supposed to see yet. Patterns. By the time governments notice, it's already too late to contain. Questions begin appearing in press briefings, asked politely, casually, as if nothing is wrong. Are agencies aware of unusual behavior from 3I ATLAS? Can you confirm reports of signal anomalies? Is there any risk to Earth? The answers are short. We are monitoring the situation. There is no cause for concern. We urge the public to remain calm. Calm is always the word used right before panic. Behind closed doors, the tone is different. Meetings stretch longer than planned. Phones stay face down on tables. Words are chosen carefully, then chosen again. No one wants to be the first to say it, because once you do, the world changes. Are we being observed? Not attacked. Not contacted. Observed. That possibility unsettles people more than invasion ever could. An invasion implies urgency, intent, action. Observation implies patience. It implies distance. It implies power. Intelligence agencies quietly request raw data, not summaries, not interpretations. Everything. They bring in experts who don't usually sit together. Astrophysicists, signal analysts, engineers, psychologists, people who study machines, people who study patterns, people who study behavior. They all notice the same thing. The object didn't change when it was noticed. It didn't react to attention. It didn't hide. It didn't escalate. It just continued. That's what scares them, because surveillance doesn't require interaction, only presence. Around the world, reactions split along familiar lines. Some people are thrilled. They feel wonder, hope, a sense that humanity might finally be part of something bigger. Others feel fear. Not screaming fear, quiet fear. The kind that sits heavy in your stomach late at night. If something artificial passed through our system without warning, what else has? Social media fills the gap where answers should be. Speculation explodes. Ancient probes, alien machines, lost civilizations, interstellar scouts. Every theory is louder than the last. But beneath the noise, a softer question hums. Why now? Why did we see this one? And why didn't it care? Astronomers try to bring the conversation back to data. They talk about uncertainty, about unknown physics, about the danger of jumping ahead, but even they feel it. The shift. For centuries, humans have looked at the stars as something distant, beautiful, untouchable. Now the stars feel closer, too close. Late-night news segments debate disclosure. Experts argue whether silence is protection or deception. Some say the public can't handle the truth. Others say the truth has already escaped. Because once you've seen the data, you can't unsee it. Behind government walls, one conclusion keeps resurfacing. If this object were hostile, we wouldn't be debating it. There would be no signals to analyze, no patterns to argue over, just consequences. That doesn't make anyone feel better, because non-hostile doesn't mean harmless. It just means uninterested. And being ignored by something far more advanced than you can feel worse than being threatened. As days pass, official statements remain unchanged. Monitoring. No threat. No comment. But unofficially, funding shifts. Telescopes retask. Observation windows extend. Eyes stay on the sky longer than before. Because if something artificial truly passed through, it may not be the last. At home, people lie awake, staring at their ceilings, wondering if the night sky they grew up with is still what they thought it was. Parents look at their children and feel something unfamiliar. Not fear for tomorrow, but uncertainty about humanity's place. And somewhere far beyond Earth, 3i ATLAS continues its journey outward. No messages, no signals aimed at us, just steady motion into the dark, as if it never came for us at all, as if we were just a moment briefly noticed, then left behind. And the question that echoes through labs, offices, and quiet rooms around the world refuses to fade. If we were observed, what did it learn? And more unsettling still, who else might be watching? Right now, something changes after that. Not in the sky, but in us. The data doesn't suddenly explode with new discoveries. No fresh signals, no dramatic turns. 3I, a TLAS, keeps moving away, growing fainter, quieter, harder to track. On paper, the story should be fading, but inside the human mind, it's just beginning. Because once you accept the possibility that 3I, ATLAS, isn't random, you can't unaccept it. A line has been crossed. For centuries, humanity has relied on models, clean explanations, equations that make the universe feel understandable, predictable, safe. We built those models carefully, brick by brick, star by star. And they worked until now. Because 3I, ATLAS, doesn't break one rule. It slips between them. Every behavior fits just enough to avoid immediate rejection, but never enough to feel complete. It's like a shadow that always stays one step ahead of the light. Scientists begin to notice something unsettling. Our models aren't wrong. They're incomplete. And incompleteness is far more dangerous than error. Error can be fixed. Incomplete truth hides things. The universe we thought we knew suddenly feels smaller than the universe that actually exists. If intelligence can exist without shouting, without building cities, without broadcasting signals, then we've been looking in the wrong places. For decades, the search focused on noise, radio waves, bright signals, loud proof that someone else was out there. But 3I, a TLAS, doesn't shout. It passes, quietly, efficiently, without ceremony. That realization lands hard, because silence isn't emptiness. Silence can be strategy. The question changes again. Not, are we alone? But, how much have we already missed? Interstellar space is vast, almost unimaginably so. Between stars, between systems, between galaxies. We always thought of it as empty. But what if it isn't? What if it's full of things that don't want to be seen? Or worse, things that don't care if they are. 3I. ATLAS forces a shift in perception that no telescope can undo. Intelligence no longer has to look like us. It doesn't need voices. It doesn't need faces. It doesn't even need purpose, we understand. It can look like motion, like restraint, like order that survives chaos. And that thought reshapes everything. Suddenly, ancient questions feel new again. How long has this been happening? How many objects have passed through our system before we learned how to notice? How many signals were dismissed as noise? How many patterns were smoothed away by models that assumed nature must always be blind? The night sky feels different now. Not threatening, but layered deeper. As if reality has a second surface we're only just beginning to see. Astronomers revisit old data, archived observations. Strange anomalies once labeled instrument error or unexplained variance. Some of them look different now, not solved, but suspicious. The universe hasn't changed. We have. That shift brings discomfort, even grief, because believing the universe is simple is comforting. Believing it follows rules we understand makes us feel safe. But 3I, ATLAS, suggests something colder. The universe may be full of things that don't need us, don't notice us, and don't explain themselves. We are not at the center. We never were. And maybe that's the truth we've been avoiding all along. There's no grand announcement, No official statement saying our understanding has changed. But quietly, in classrooms, labs, and late-night conversations, something cracks. Certainty. The idea that if intelligence existed, we would know. The idea that silence meant absence. 3I. A T-L-A-S proves silence can mean something else entirely. It can mean passing through unnoticed. And if intelligence can hide inside the unknown, then the universe may have been watching us grow, argue, evolve, without ever needing to say hello. That thought doesn't inspire panic. It inspires humility, a deep, unsettling humility. Because now we understand something painful. The universe doesn't owe us revelation. It doesn't owe us clarity. And it certainly doesn't owe us importance. 3I, a T-L-A-S, didn't arrive to change humanity. It arrived to remind us of where we stand. Small, curious, and only just beginning to see. As the object fades into the dark, beyond our strongest instruments, it leaves something behind. Not answers. Perspective. And the final question lingers longer than any signal ever could. If intelligence has been passing us in silence, how long has it been there? And how long before we learn to truly see it? It doesn't fade. That's the strange part. There's no warning, no weakening, no slow decline that gives anyone time to prepare. One moment, the pulse is there, steady, familiar, almost expected. The next moment, nothing. At first, no one believes it. Someone assumes a technical error, a dropped connection, a corrupted file. Signals vanish all the time for boring reasons, so they refresh the feed, restart the system, check the timestamps. Still nothing. The chart stays flat, a clean, silent line where a rhythm used to live. They wait. Minutes pass, then more. The pulse doesn't return. That's when unease turns into something heavier, because when natural phenomena stop, they usually leave scars. Noise, aftershocks, residue. This leaves numb. No decay, no distortion, no final burst of energy. Just absence, as if someone flipped a switch. Across observatories, the same reports come in. Signal gone. Pulse terminated. No anomaly detected. The words feel wrong. You don't terminate noise. You terminate processes. Scientists stare at empty charts longer than they should, as if waiting for the signal to reappear out of embarrassment. It never does. The silence feels intentional. Not broken, finished. That's what unsettles people most. If the pulse had faded slowly, it could have been explained. Distance, energy loss, weakening emissions. But this feels like a decision, as if the signal had served its purpose. And now it was no longer needed. Some check to see if perihelion has changed anything. Others compare distance and timing. They search for correlations that could make this feel natural. None appear. The pulse doesn't end because conditions change. Conditions change after the pulse ends. That order matters. Because cause usually comes before effect. Here, it feels reversed. A few people quietly ask the question no one wants to hear out loud. What if the signal wasn't failing? What if it was stopping? Stopping implies choice. Choice implies awareness. And awareness implies something watching long enough to know when to stop. that idea spreads quickly and silently. No emails, no official notes, just glances across rooms. Longer pauses in conversation. The signal had become a constant, something to measure time by, something to anchor uncertainty. Now it's gone, and the emptiness it leaves behind feels louder than the pulse ever was. Some feel relief. Maybe this was the end. A strange chapter closed. A mystery that simply burned out. Others feel the opposite, because endings usually feel like endings. This feels unfinished. The object itself is still there, fading, distant, moving away. But whatever behavior once defined it has gone dark. No pulses, no active response, no visible effort, just motion, like a machine returning to idle. Or worse, a machine that has completed its task. That thought refuses to leave. What was the task? Was the pulse diagnostic? A calibration? A check-in? Was it internal or external? No one knows, and that's the problem. When something strange begins, humans search for meaning. When it ends abruptly, we search for intent. The absence becomes the message. Somewhere deep inside the data, a final timestamp sits quietly. The last pulse, perfectly formed, perfectly timed. Then silence. No farewell, no acknowledgement, just withdrawal, as if the universe leaned close, showed us something, then stepped back into the dark. People start asking a question that feels almost childish, but impossible to ignore. Was that it? Was that the only moment we were meant to notice? Or was that just the beginning of something much larger? Something we aren't ready to see yet. The charts stay empty, the sky stays calm. Life on Earth goes on. But the feeling doesn't fade, because the signal didn't end the way natural things end. It ended the way decisions end, cleanly, and that leaves humanity standing in the quiet aftermath, staring at silence and realizing something unsettling. Whatever was out there, it didn't disappear. It simply stopped speaking. And when something that never explained itself goes quiet, you're left with only one question. Did it leave because it was finished with us? Or because it never needed us at all? The silence doesn't answer. It just waits. And in that waiting, a final thought begins to form. Slowly, reluctantly. Sometimes the most important moment isn't when something arrives, it's when it decides to stop. In the end, there is no explosion, no revelation. No final message written in light across the sky. 3I ATLAS simply keeps going. Day by day, it drifts farther from the sun, farther from Earth. Its signal is gone. Its pulse silent, its behavior calm and unchanged, unbroken, as if nothing ever happened. Telescopes still track it, but the data grows thinner now, fainter, harder to hold on to, like a voice disappearing down a long hallway. Eventually, even the most powerful instruments struggle to follow it. And then, one night, it slips beyond meaningful observation. Not dramatically, just quietly, the inner solar system returns to normal. The sun burns the way it always has. Comets come and go. Space resumes its familiar rhythm. On the surface, it feels like closure. But underneath, nothing feels resolved. The data remains. Stored, archived, copied, studied again and again by people who still can't make it fit. Every anomaly is still there. Every pattern still intact. Every unanswered question still waiting. 3I ATLAS didn't leave behind destruction. It left behind doubt. For scientists, that doubt is heavy, not because they failed, but because they may have succeeded too well. They saw something they can't explain. And once knowledge reaches that point, there's no going back. For the rest of humanity, the effect is quieter, harder to name. A subtle shift in how the night sky feels. The stars look the same, but they don't feel the same. Because now we know something unsettling. Discovery doesn't always bring truth. Sometimes it brings awareness. Awareness that the universe is deeper than our maps. Awareness that intelligence may not announce itself. Awareness that silence does not mean absence. 3I ATLAS didn't answer our questions. It reframed them. We used to ask, are we alone? Now the question feels different. Have we ever truly been alone? The idea settles slowly. What if the universe is filled with quiet travelers? With machines, relics, systems moving between stars, never stopping, never speaking, never caring who notices? What if Earth was never meant to be contacted, only passed? That thought doesn't inspire fear. It inspires humility, because it reminds us that we are not the final chapter of the cosmos. We are a sentence, a paragraph, a moment, and moments pass. 3I ATLAS passed, not as a warning, not as a greeting, but as a mirror. It showed us how much we still don't see, how much we assume, how much we believe the universe must behave in ways that make us comfortable. But the universe owes us nothing. Not answers, not meaning, not reassurance. Sometimes it offers only a glimpse and then moves on. Years from now, people will still debate what 3I ATLAS was. Natural anomaly, artificial artifact, something else entirely. New models will emerge. New explanations will try to close the gap. Some may succeed, some may fail. But one thing will remain unchanged. That moment when the data stopped making sense, and humanity realized it was standing at the edge of a much larger reality. 3I ATLAS didn't change the universe. It changed our perception of it. And perception, once shifted, never fully returns. The sky hasn't spoken since, but maybe it never needed to. Maybe the message was never in the signal, or the pulse, or the heat. Maybe the message was this: the universe is not empty. It is not simple. And it is not waiting for us to be ready. It moves, it observes, it continues, with or without witnesses. And as Earth spins quietly beneath the stars, one final realization settles in. Soft, unsettling, impossible to forget. Discovery doesn't always bring truth. Sometimes it brings awakening. And awakening is not the end of the story. It's the moment you realize how much of the story has already passed in silence.